Okay, numbers 1 and 2 were done. The first one is just using central angle equals arc measure, so it was nice and easy, just 115 equals that 115 degrees. But for number 2, we had 360 for the whole circle, minus the 99 gives us that back arc. This key is attached in the bin too for reference. Okay, so next one says, if AC is equal to 4.5, so check this out, this little piece here is equal to 4.5. What is the measure of the whole chord? And if you guys remember, I'm going to go back to the little justifications page. You're looking for a picture that looks like this, and we see the radius perpendicular chord, radius bisects chord theorem. This guy right here. Okay, radius perpendicular chord, radius bisects chord theorem. So I'm going to go over and write that in. Oops. So it's the radius perpendicular chord and then radius bisects chord theorem. Now, if you notice, both of these numbers 3 and 4 are both using this as their justification. So what does this theorem say? It says if this radius is perpendicular to this, then I know that the little piece is 4.5 and the other little piece will also be 4.5 because they're bisected. And you guys might not remember the name of this theorem, but you knew that it was a 4.5 and a 4.5. So for the entire length AB, the whole chord, it's both the 4.5s together or just 9. This is going to be U for units because it's the measure of the length of a chord. Okay. Next one's the same theorem. If this is perpendicular and XZ is 14, the whole thing is 14, then what's the measure of just YZ? This little guy right here. And we know that that has to be a 7 and a 7 if that adds up to 14. So we say that YZ equals 7U for units. And our reason is, again, radius perpendicular to the chord means that the radius bisects the chord. And remember to highlight those answers. 9 units, 7 units. Any questions on 3 or 4 using that radius perpendicular chord, radius bisects the chord theorem? All right, for 5 and 6, we've got some inscribed angles. Are you starting to recognize these, even if you don't remember the names? You recognize that that is not your central angle anymore. Okay, so this one right here is asking for the measure of YZ. And so using the inscribed angle theorem, this theorem tells me that the measure of this angle is half the measure of that intercepted arc. The measure of that inscribed angle is half the measure of the intercepted arc. So if I want the arc YZ, I have to double angle YXZ. So I have to double the 32. So I get 64 degrees for the measure of that arc. And doesn't it kind of look like a big intercepted arc compared to a little tiny angle? So it makes sense that if I'm starting inside and going out, it should get bigger. And if I'm starting outside and moving in, it should get smaller. That answer is 64 degrees. Using this same rule, inscribed angle theorem, we're going to go do the other one. But this time, they're not just asking for little bc. No, they're asking for the big outside arc, BAC. So this is what I called the two-stepper, where because this little angle in here is a 21, we know that this outside arc is a 42. We can double it. We can say that the measure of BC is double the measure of angle BAC, or double the 21. So we could get that 42 degrees, but they didn't ask us for BAC. They asked us for the big major arc. So we know that the measure of BC and the measure of that major arc add up to 360, because whole circle equals 360. So now I can go plug in that this is a 42 plus our unknown. And then grab those calculators and subtract that for us. And you don't have to make this an X. You can keep this as the measure of BAC, and then the measure of major arc BAC. Okay, somebody subtract that for us. What is 360 minus 42? Thank you, Aurora. 318 degrees it is. I hope you guys got the same thing as Aurora. Make sure you highlight those answers. In 1 second, I'm going to scroll down to the next one. Any questions before I start scrolling on that one? All right, here comes the next one. Hopefully you got that okay. All right, now these were technically the extra credit 5.6, and these are going to be on the test as extra credit bonus on the test. So if you didn't do these next couple, watch these right now and you can still get the extra credit on the test, even if you didn't do the extra credit study guide and quizzes. All right. All right, so the rule for this one says that the measure of this little angle in here is equal to half of the major arc minus the minor arc. So let's first write out the rule. Measure of angle BDC is equal to half the measure of the major minus the minor arcs. And so I'm going to just go over to the justifications page so you can see where this is. If I scroll down to a picture that looks like it, do you guys see way down here at the very bottom how it's called the tangent angle theorem? Because it's got this, oh, sorry, this one's not tangent. This one here, the secant angle theorem, because they're going through. So the measure of the angle is equal to half of the measure of the big arc minus the small arc, the major minus the minor. So it's right here listed on this page for you to use for reference. Secant secant angle theorem. And a secant is a line that goes through your circle. It's not a chord, it keeps going past the circle. Okay, so let's go fill in these numbers. Notice that my major arc is 42 and my minor arc is 15. So that's what I'm going to go plug in. Half of 42 minus 15 would be half. I'm going to grab my calculator. 42 minus 15 is 27. And so half of 27 is going to be 13.5 degrees. Okay. Now this next one is the tangent tangent because it doesn't go through the circle. It just has one point of tangency. So tangent tangent angle theorem, but it's literally the exact same rule as the secant secant. Yay! Only one rule to remember. It's the same thing. If I go over here and look at the very bottom, see how it's still subtracting the big minus the little arc? Well, that's nice. It's one section, but one rule. Two different theorems, but one rule. So let's go write this one down. It's telling us that the measure of CAB is equal to half the measure of the major minus the minor. So remember that my major, let's use the same colors. My major is this guy right here. The 265 goes first. And then my minor is this little guy right here. The 95 goes last. Okay, I need some help from somebody with a calculator. Somebody do the 265 minus 95 for us. What is 265 minus 95 going to give us? Thank you, Savannah and Jada. Can you girls now divide that by 2? And Miguel, thank you. Thank you, Miguel. And that is degrees because we're finding the measure of an angle. Okay, so these two, again, are the extra credit that if you do them on the test, you get extra credit on the test. And you can still do the 5.6 quiz for extra credit if you want. Okay, I'm going to skip to number 10 because it's the same thing. Notice that number 10 looks just like number 7, where it's the secant angle theorem. Measure of angle EAD is equal to half the measure of the major minus the minor. Take a minute to go as far as you can on this. Jordan, is it working better with your data? Okay. Jordan, the recording of me doing this right now with your class will get posted right at the end of the period. So you can go back and watch it if you need to. All right, how'd you do? For 125 minus 31, did you guys get 94? And then did you divide that by 2 and get 47? Remember on this test in person to please highlight your answers. Okay, so what the heck is this other one over here? The measure of AC is 142. So this guy right here, not the line, the arc is 142. What is the measure of CAB? So what's the rule for this little angle right here? So going back to our justifications page, do you see that this is called the tangent chord theorem right here? Tangent chord theorem. It says that the measure of the tangent chord angle is half the measure of the arc. Okay, so tangent chord. Right here, guys, tangent chord angle theorem. And it says that the measure of angle CAB is half the measure of that arc AC. So it's similar to that intercepted arc rule, like the inscribed angle theorem. And so half of the 142 is just 71 degrees. Oop. Okay, if you're done, see how this is at the bottom of the page again, you guys? If you're done with numbers 9 and 10, please type ready over in the chat for me. Okay. Moving down, this one is also the tangent. And this one over here is also, so number 11 is just like number 10. Sorry, just like number, where's our tangent? Just like number 8. And number 12 is just like number 9. Using this guy right here, the tangent chord angle theorem. Okay, so I'm skipping numbers 11 and 12 that are just like number 8 and like number 9. If you want to keep practicing those, feel free. Okay, next, circumference and area. Find the circumference of a circle with a radius of 4.5. So remember that these formulas are back at the beginning. So my circumference is 2 pi r, and they're saying that the radius is 4.5. 4.5 times 2 would be 9 pi. Remember that circumference is U for units. It doesn't say anything else. And this is my exact answer before I have to round. Now I take the 9 and I multiply it by 3.14. Grab your calculators. And I get 28.26 U for units. So there's a decimal and an exact answer. If I round, I have to use the approximation symbol. Here I did not have to round. Okay, find the circumference of a circle with a diameter of 22. Remember that we can also do circumference equals pi times diameter, because 2 radii is a diameter. So this time it's pi times 22, or 22 pi U for units. And then we multiply that by the 3.14. Let's see what this gives us. Again, doesn't need to be rounded, 69.08 U for units. This is known as the exact and decimal answers, or exact and rounded answers. This is for the full circumference, and this is for using both of the different formulas. So we wanted to do just an arc length, not the full circumference for our math 2. So for example, what is this? If the circumference of the circle below is 25, so they're telling us that this whole thing is 25. What is the length of AB? So remember our little formula. It says the measure of arc AB, sorry, not the measure, the length of arc AB is equal to my part of the 360 times the whole circumference. So it's going to be 70 out of 360 of the whole circumference. So we do 70 divided by 360 times 25. And remember that the circumference and arc length are all just in U for units. Finally, if AB measures 155, what is the length of the radius and the circle to the nearest hundredths? We're skipping number 16. There's not going to be anything like this on the test that you guys are going to have to work backwards to find the radius. Okay, because I'm close on time. I only wanted to go to 8:35 today. Remember, this key will be attached here. I want to scroll down to these little areas. So remember that our area is equal to pi radius squared. And our pi is going to be times the 4.5 squared. And this time the radius is 14 units, so it's 14 squared. So area, they're reminding you first of the full formula, but what are we going to have to do on this test? The area of a sector. So let's go down and focus on those two last ones. So it's asking for the area of the sector is equal to my part of the whole 360 times the pi r squared of my circle. Same for this one. You'll notice it's just a bigger area, 255 out of 360, the shaded area, this whole thing here, times pi radius squared. So now we multiply this out and we're going to reduce. I'm going to get 49 pi for the full area, and 62 and 360, I'm just going to start with dividing by 2. 62 divided by 2 is 31 over 180. And then let's just multiply it out and see if it reduces. 31 times 49, that's going to be 1519 pi on top over 180. And I don't even think that can reduce. I think that's our exact answer. That's unit squared. But now let's go just multiply it out. 62 divided by 360. My decimal is 0.1722 times the 49 times the 3.14. And I get a rounded answer, 26.50. It rounds up, units squared. This is finding the area of a sector. Remember that you're going to give me the answer in both the exact and approximate. And you guys are going to get a much easier fraction on the real test. Finally, let's do the last one. This is going to come out to 225 pi for the area. So 255 over 360 times 225 pi. And I can tell that 5 goes in. So 360 divided by 5 is 72. 255 divided by 5 is 51. 51 times 225 is 11,475. And that can be divided by 3. So we're going to go 3825 pi. Actually, it can be divided by 6 at least. Let's see if it can be divided by 12. No. No. Okay, so 72, it could just be divided by 3, guys. Okay, and this is units squared. And then we go way back up to the top and we do the approximate answer. 255 divided by 360 is 0.7083 times the 225 times the 3.14. And we get 500.44 units squared. Okay, homework tonight is to start the practice test if you can. We're going to do the entire practice test together before we do the test in class. So go look at the homework, see if you're going to have time to try it on your own, and we're going to go over all the answers before the test in person. Any final questions from you guys before I let you head on